let's try to do few questions about Williamson synthesis. That's also an important portion of +2 organic chemistry. Now this reaction is known as Williamson synthesis. We are reacting Rx molecule with RONA and we are getting a ether plus NaX is liberated as a side product. Now this is the simple SN2 mechanism reaction. RO negative will attack this R from the back side and we will get ROR as ethers. Now let's try to attempt few questions regarding Williamson synthesis. Now let's first discuss about these 4 questions about Williamson synthesis. Now from this expression we can clearly see that RONA reacts with Rx to form ROR, that is a ether. Now by going by this particular general reaction we can see that the ether formed in this first question will be CH3 CH2 OCH2 CH3, that is a diethyl ether. Now the first thing we must avoid in this particular question is not to write like this. This is wrong. Now let's move on to the next question. We have CH3 CH3, that is tertiary butyl group that is attached with ONA reacting with CH3Br. Now again, going by the generalized expression, RONA reacts with Rx, going by SN2 mechanism, it will form a ether. So the product formed in this reaction will be that is tertiary butyl methyl ether. Now moving on to the next question, we have phenyl group ONA reacting with CH3Br. Again Going by the general expression, RONA reacts with RX going by SN2 mechanism, ethers are formed. So we can obtain a molecule of any sol from sodium phenoxide by Williamson synthesis. Now the last question. Now this compound is a allylic halide. Br is attached to allylic carbon. Again, going by the generalized expression, your RONA reacts with RX. Going by SN2 mechanism, ethers are formed. Again, we must avoid to write like this. So these are the few products that are obtained from Williamson synthesis. This is a simple SN2 mechanism. Nucleophile is attacking from the back side. We will get an inverted product. Now, let's try to do one more question. Now, this one is very interesting and important also. Now, if we go by the general mechanism, general reaction, RONA reacts with RX to form ROR and NAX. Now, in this particular case, if we follow this mechanism or this reaction, we might think that Br will be released from here and Na from here, and the product will be this ether. Which is actually the wrong answer. Now, you have to be very careful about this particular question. We will not get this type of ether by reacting a tertiary butyl bromide with RONA. Now, what's the reason behind this? Why we are not getting this particular ether? Now, if we see this compound, this is a 3-degree halide. Now, how can we say that whether a compound is 1-degree halide or a 2-degree halide or a 3-degree halide? Actually, we take care about the carbon that is directly attached with the halogen. I'm marking it as a star. Next, we will see how many further carbons are attached to this star one. So here we have first, the second one, and the third one. So this is a 3-degree halide. Now if we remember, 3-degree halides, they prefer elimination reaction over substitution reactions. If we go by SN2 mechanism, they are the least reactive ones for SN2 mechanism. Hence, in this case, now, what's going on here? Instead of showing the general reaction of RONA reacting with RX to form ROR, we are obtaining alkene as the product. So 3-degree halides, while reacting with RONA, they prefer to form alkene, a molecule of alcohol, and NABR. Now basically what is happening here is now this Br is ready to move out, but this alkoxide ion, instead of attacking this carbon from the backside, will prefer to abstract a proton from here. So we are getting a alkene. Here it is occurring dehydro halogenation reaction. Your hydrogen is removed, your halogen is removed. So we say that this is a dehydro halogenation reaction. The first molecule obtained is alkene. The second one is the alkoxide ion attacking this H, that is forming a formation of a alcohol. And the last one is your Na reacting with Br to form NABR. So we have to take care of this last question. If tertiary halide is reacted with C2H5ONa, we won't get this type of ether. Now let's discuss about one more reaction, which is again very important. Now, let's see what will be the product of reaction of CH3ONa with bromobenzene. Now, if we go by the general reaction of Williamson synthesis, we can see that RONA reacts with RX, Going by SN2 mechanism, we are getting ROR, that is a ether plus NaX is evolved. But if we follow the general reaction, we might think that NaBr will be out and we will obtain this type of ether, which is actually wrong answer. Now again, why? Why we cannot obtain any sol by reacting bromobenzene with CH3ONa? Now this is a haloarene. This molecule is, generalized name of this molecule will be haloarene or aryl halides, that is a bromobenzene. Now if you are a student of +2 class, you might have heard about the nucleophilic substitution reactions of haloalkanes and haloarenes. In that topic, we have studied that haloarenes, they are less reactive towards nucleophilic substitution reaction as compared to haloalkanes. Now we have seen there are basically one or two explanations for that. First thing is, if you want to do nucleophilic substitution reaction of a haloarene, this phenyl carbocation is not a stable species. This is the first reason. The second reason is that aryl halides, because of the presence of lone pairs on halogens, they basically donate the lone pair towards the ring, showing the plus R effect, which will basically lead to resonance, and here we will have a double bond. So instead of a single bond, in the case of haloarenes, we have a double bond, which is again not a good factor for the breakage of this bond. And the second thing is this phenyl carbocation, that is not a stable species. So this is the reason why haloarenes or aryl halides, they are less reactive towards nucleophilic substitution reactions as compared to the alkyl halides. So what will be the product of this reaction? Our answer will be, there will be no reaction. There will be no reaction. Why? Because aryl halides, they are not reactive towards nucleophilic substitution reactions. I hope you are clear with the basic fundas of Williamson synthesis and the important questions regarding Williamson synthesis, especially this one, this last one of tertiary halide, where we might think that this will be the ether, but that is again the wrong option. We will obtain a molecule of alkene, alcohol and NABR. And another one is this particular reaction of aryl halide reacting with RONA. Again, the answer will be no reaction. We might think that this will be the correct option. So please take care of these two questions while attempting your organic chemistry exam. Okay, have a nice night. Good night.